Have you ever pondered the mysteries of how metals and non-metals react with dilute acids and water? There's much to learn from this captivating subject, which takes us into the core of chemistry. First, we plunge into the realm of metals. Envision a sliver of zinc-magnesium. When these metals meet dilute acids like hydrochloric or sulfuric acid, a fierce reaction ensues. Hydrogen gas is emitted, forming a corresponding metal salt. An example is zinc's reaction with hydrochloric acid, generating zinc chloride and hydrogen gas. This phenomenon, termed a displacement reaction, highlights the potent nature of metals upon contact with dilute acids. Now, consider copper or silver. These metals oddly show no reaction with dilute acids. This peculiarity is due to the reactivity of the metal, with copper and silver remaining unreactive due to their lesser reactivity. So, while some metals react vigorously with acids, others like copper and silver stand strong against the corrosive nature of these substances, offering a testament to the diversity of reactions in the chemical world. This trait depends on the reactivity of the metal, and copper and silver, being less reactive, stay unreactive with dilute acids. Now let's turn our attention to nonmetals. Nonmetals, such as carbon or sulfur, have intriguing characteristics that set them apart in the world of chemistry. Unlike metals, these do not interact with dilute acids in the same way. When you look at elements on the periodic table, you will notice that carbon and sulfur fall into the non-metals category. They are unique, not just in their physical properties, but also regarding their chemical behavior. A key distinction here lies in the fact that non-metals like carbon or sulfur do not show any noticeable reaction when exposed to dilute acids. This characteristic is quite intriguing and contrary to what we observe in metals. Metals, as we've explored before, have the potential to react quite strongly in the presence of dilute acids, showcasing a level of vigor and in their chemical reactions. However, when it comes to nonmetals, the scenario changes completely. They are much more reserved in their interactions, demonstrating a minimalistic approach when mixed with dilute acids. Their reaction, or rather the lack of it, is a curious phenomenon that intrigues chemists and students alike. Nonmetals, on the other hand, are more reserved, showing little to no reaction when mixed with dilute acids. But what happens when metals and nonmetals encounter water? This is a question that has intrigued scientists and researchers for centuries, leading to countless experiments and studies. Metals, as we know, are robust and lustrous materials that are good conductors of heat and electricity. Nonmetals, on the other hand, are a different breed entirely. They are generally poor conductors of heat and electricity and are not metallic in appearance. When metals come into contact with water, the reaction can be quite exciting, even dramatic. Metals undergo a chemical process, reacting with water to form what scientists call metal hydroxides and hydrogen gas. Let's take sodium as a representative example. Sodium is a common metal, quite reactive and known for its bright silvery white. When sodium encounters water, there's a chemical reaction that leads to the formation of sodium hydroxide and hydrogen gas. This reaction is not just any ordinary occurrence, it's exothermic, a scientific term that describes a process that releases heat. And let's not forget, this reaction can be quite explosive with reactive metals. In stark contrast, nonmetals put on a completely different show. They behave in a surprisingly different manner when they come in contact with water. Under normal conditions, nonmetals do not react with water. They maintain a stoic, unchanging demeanor, refusing to react no matter how much the water attempts to engage with them to provoke a reaction. It's as though they are impervious to the water's advances, maintaining their composure and indifference under all circumstances. This distinctive behavior gives them a unique place in the world of chemistry. Nonmetals, however, do not react with water under normal conditions. They maintain their stoic indifference, refusing to react no matter how much the water tries to provoke a reaction. In summary, metals and nonmetals exhibit contrasting behaviors when reacting with dilute acids and water. Metals often engage in fervent reactions with these substances, culminating in the formation of metal salts and the emission of hydrogen gas, thereby illustrating their reactivity. In stark contrast, nonmetals usually remain non-reactive, emphasizing their unreactive disposition. The reaction of metals with dilute acids is particularly captivating as it fluctuates based on their reactivity. Metals such as copper and silver, known for their lesser reactivity, often exhibit no reaction whatsoever, while others engage in robust reactions. When it comes to water, the situation mirrors the former. Metals react to spawn metal hydroxides and emit hydrogen gas in a reaction that liberates heat and is thus exothermic. Non-metals, conversely, maintain their non-reactivity with water, thereby underlining their distinct traits. The next time you encounter a metal or a non-metal, bear in mind the veiled chemistry it encapsulates. Regardless of their simplicity or complexity, these reactions contribute to the intricate mosaic that constitutes our universe. Signing off, remember chemistry is all around us, from the air we breathe to the ground we walk on. So keep exploring, keep learning, and keep having fun with chemistry. Voiceover. Now, let's dive into some fascinating facts about metals and non-metals that you might not be aware of. It's time for our Did You Know segment. Did you know that gold is the only metal that is naturally yellow or golden? Other metals may develop a yellowish color, but that's only after they have oxidized or reacted with other chemicals. It's one of the reasons why gold has been prized throughout human history for its unique and unchanging beauty. Switching gears to non-metals, they are not able to conduct electricity or heat very well, which is completely opposite to metals, which are excellent conductors. This is why, for example, the wires in your house are made of metal and the plugs and switches are made of plastic, a non-metal. And here's a bonus fact for you. The only non-metal that is liquid at room temperature is bromine. Unlike most non-metals, which are typically gases or brittle solids, bromine stands out with its red-brown liquid state. Isn't it fascinating how metals and non-metals, which we encounter in our daily lives, possess such unique and diverse characteristics? Stay curious, keep exploring, and remember, chemistry is all around us. Voiceover. Well, we've reached the end of our journey today, folks. I hope you enjoyed this exploration of the intriguing world of metals and non-metals. It's been a pleasure to share these fascinating facts and experiments with you. Remember, the realm of chemistry is vast and full of wonders waiting to be discovered. There's always something new to learn, to understand, and to marvel at. So don't stop here. Keep asking questions, stay curious, and keep exploring the amazing world around you. This is Junior Impossible signing off for now, but remember, the adventure of learning never ends. Until next time, my friends, stay curious and keep exploring.